Welcome back, my dear friends. A very good morning, good afternoon, good evening to wherever you are in this part of this world. Maybe you are in India or outside India. And as you know, this is the DADM, which is Data Analysis and Decision Making 2 course under the NPTEL MOOC series. And this total course duration is for 12 weeks, which is 30 hours. And each week we have which would totally be 60 lectures. The reason being each lecture is for half an hour, and the total duration, as I said, was 12 weeks, and each week we had 5 lectures, and after each week we had assignments. And as you can see, my name is Raghunandan Sengupta from the IME department at IIT Kanpur, and we are going to start today the week. We have already completed 30 classes. We are going to start the 31st class. That means we are going to the 7th week. Now, if you remember, in the last whole 1 week we had in this, which was in the 6th week, we had all the discussions about Electra method and what was the basic concepts of Electra, the normal Electra method, the epsilon Electra method, how normalization could be done along the rows or along the columns, keeping in mind the utility function, and also keeping in mind that in the direction where you are doing the normalization, the sum should add up to 1. And technically you had 2 different matrices, one was the weightage one, and we also consider initially, I should mention that there were m number of such alternatives, I is equal to 1 to m, small m, and there were n number of criteria or decision what you call characteristics, based on which you will take the decision for any alternative, and that changed that was nomenclature through j is equal to 1 to n. Now, once you are doing the normalization, remember the normalization would be based on the fact that what type of utility function which you have, and we had already discussed in quite earlier that if your utility function is quadratic, your returns for the investment, whatever the decision is, would be normal in nature and vice versa. And we will try to basically either maximize your expected value of the utility or minimize the variance of the utility, or whatever combination you want to do. Like you want to take the ratio of the expected value divided by the variance and rank them from the highest to the lowest, or take the ratio of the variance to the expected value and rank them from the lowest to the highest. You can take different course of action. And in the Electra method, if you remember, we had the concept in general Electra, the concordance set and the discordance set. Concordance sets are those values of j's. J's means basically 1 to n, those values of the criteria which give you positive benefit for taking the decision a k with respect to a l. K and l are some values of n, and a being the as the nomenclature was given, was the alternative. And you will basically club them in the concordance set, in the discordance set, then find out the concordance indices, discordance indices, then found out the values of the matrices, which was capital C and capital D, and then you found out the corresponding values of G and F, which was when you compare the values of using the concordance set and compare the values using the discordance set. And then once G and F were given, you multiply each element of G, that means G I J. Here I and J does not have any such connotation with respect to M and N. Multiply that value of G with respect to value of F, G and F, as I said, F I J, and basically get the corresponding cell value of E. E was basically the combined concordance discordance matrix value, and then you can basically find out which decision alternative helps you with respect to the combination of the alternatives. And the weights, if you remember, were predefined depending on the overall weightages or overall importance the person decision maker used to give on each and every alternative base for each and every criteria. Now, in the epsilon case, we consider the whole set of criteria being divided into 3 mutually exclusive and exhaustive sets. One was basically definitely positive when A k's value with respect to that criteria was greater than A l. In another case, the A k value was less than A l, and in another case when it was in between, we basically had the indifferent set I such that you are indifferent whether you take A k. Then when you reverse the decision in the case when you are taking A l, and obviously there would be corresponding value of concordance discordance, and this concept of concordance discordance need not be always positive and negative going hand in hand. It may be possible, and we will see that later also in the Topsis method. I am sorry I am going a little bit more into the depth of the explanation. In the Topsis method, you will also see, as we saw in the Electra method, that if I like or if a decision maker likes alternative k A k with respect to A l for any of the criteria, say for example, I 1 means suffix 1, it and it gives, say for example, some positive value, some quantum, say for example 10. It does not mean that when the person takes the decision A l with respect to A k, the value would be something minus 10. It can be, say for example, plus 5 also. That means, whether I take k or whether I take A l, I will get a benefit in both the cases. So, whenever you are trying to basically find out the that matrix C or matrix D, it basically that will give you the information that what is the cumulative concordance values and the discordant values I am going to get by taking either the kth one or the lth one or the alternative based on all the corresponding criteria which I have. And similarly, in the case of those of this epsilon concept of Electra, I have basically divided the whole set of the criteria into 3 sets, that is C, D and I. That means, C as usual the concordance matrix, D as usual the discordance matrix, and I would be the indifferent matrix based on which I will try to combine. When I combine, I basically try to find out what is the value of that alternative with respect to the criteria when I am considering the combination of C to I, that means concordance with respect to indifference, then concordance with respect to concordance, concordance with respect to discordance. Then basically again I go into the second set of comparison, where I compare indifference to concordance, indifference to indifference and indifference to discordance, and finally I come to the fact where I compare discordance to concordance, discordance to indifferent and discordance to discordance. Based on that, we have those values of G and F. G would now be corresponding to C and F would be corresponding to C. Then similarly, G and F would be corresponding to I and G and F would be corresponding to the discordance, and then we combine them to find out the overall matrix E, which will give me the comparison that cumulatively when I compare the concordance, discordance and indifference sets and the values, what is the overall ranking of the alternative based on the cumulative criteria. Now, in this method, in the Topsis method, the basic concept is almost the same. Here also we will group them into 3 sets or 2 sets depending on whichever policy we are following, but the and also the fact remains that the utility function will be used, normalization concept will be used. So, when a person is trying to basically make a comparison, so there would definitely be m number of alternatives, I is equal to 1 to m, there would be n number of criteria, j is equal to 1 to n, and we will compare A k to A l, A suffix k, that means the kth alternative corresponding to the fact that I am comparing with the lth alternative based on each and every criteria. But here the fact is that I will consider hypothetical the best set of alternative which will give me the best benefit some point means some decision set. Similarly, I will have the worst set or the non-ideal set. These are all theoretical values, that means the best set would never may be utilized, but we will try to find out in order to compare. Similarly, we will find out the worst set or the non-ideal one, and later on also we will try to find out the comparison of the best ideal and the worst ideal in order to compare, and what is the concept of distances. Now, these distance functions will be utilized in such a way that we will consider the Euclidean distance. Euclidean distance means, say for example, I am at x1 y1 point and I want to find out what is the distance from that coordinate in the 2 dimensional one to from x1 y1 to x2 y2. I will basically find out the difference between these points, that means x2 minus x1 whole square plus y2 minus y2 minus y1 whole square and square root of that. So, we will try to follow this Euclidean distance, which would have some semblance with the concept of the Euclid function, which is quadratic, because the quadratic concept will give us two important things. Point 1, that if quadratic Euclid function used, we know that we can safely use the normality distribution for the returns, point 1. And point 2, also remember, when we try to find out the variance of the quadratic Euclid function and try to basically find out the minimum of that depending on the deviation, we will always see to the fact that we will basically try to minimize the variance, which is what we want. And if you remember, in the quadratic Euclid function or the quadratic loss function which we have used, the squared error loss function, this concept comes out time and again. So, with this small introduction, I will basically start the concept of the Topsis. So, this, as I said, would be the 31st lecture and which is the starting of the 7th week. Now, the technique for order preference by similarity to ideal solution, which is known as the Topsis, and this method was developed for the integrated human exploration mission simulation facility, which were basically utilized for the project in the Johnson Space Center to assess the priority of a set of human spaceflight missions simulators. So, you basically they were simulating different type of spaceflight environment, and based on that the concept that how you will basically try to find out the least distance and the worst distance, or the best distance and the furthest distance in such a way that you can find out which are the best set of solutions and which are the worst sets of solution depending on the different type of criteria which you have. So, you are trying to basically compose a set of alternatives which are best, compose a set of alternatives which are worst, based on the fact that you will basically find out a cumulative overall weightages based on the criteria. In this case of Topsis, we will assume the utility function is monotonic, it is increasing and decreasing, in the sense that more you have it, more you will want, less of any positive value you will have, less you will want of that. In the sense that positive less I am basically putting the positive sense, but technically that if it is a positive thing, more I take, more I want. That means, the first derivative of that positive function will always be positive. In the sense, if you remember the concept of utility, we have considered that u which is a utility function will be always increasing, and that increase can happen in 3 ways. One is increasing at an increasing rate, increasing at a constant rate, and increasing at decreasing rate. So, but in all these cases we will consider the concept that u prime would always be positive. So, obviously, u double prime may be greater than 0, may be equal to 0, may be less than 0. Now, in the case when I use the word less, it means that if there is some negative value accruing due to my decision making ability, then obviously I will try to reduce the level of negativity as far as possible. That means, positivity is more I want, negativity is less I want, and this concept of increase and decrease will continue to whichever level of the utility or the value of wealth or the value of decision I am going to take, or based on the criteria. That means, if I increase the value of the criteria and if it is giving me positive values, I will continue increasing it. If I increase the value of the criteria and the value of that overall decision is giving me negative values, that means, it is giving me not positive or decreasing positive values, then I will obviously I will try to decrease it as fast as possible. That means, make the values 0 in the negative sense. The basic premise based on which Topsis method works is the fact that selected alternatives, that means A k and A l, which we are taking, and these are the sets of all combined together alternatives which are basically from 1 to m. So, hence the selected alternative should have the shortest distance from the positive ideal solution and the furthest distance from the negative ideal solution. So, what we want is that we will have a theoretical value, the positive set, by taking a combination of the criteria and the alternatives when they are being combined, and we will take the negative value in the sense that for some sets of criteria we will find out some sets of alternatives which will give us the negative value, the worst so called value. So, we will try to find out the theoretical positive value, theoretical negative value, and try to compare the distances of each and every alternative from those theoretical positive and theoretical negative values, and try to find out how far we are. So, closer we are to the positive ideal solution, better the alternative is, further we are from the negative ideal solution, better we are. So, obviously, it means that closer I should be to the positive sense, further I should be from the negative sense. So, when I basically try to compare the other way around, that if I am further away from the positive one and more closer to the negative one, obviously it will mean a bad decision or bad alternative based on the cumulative criteria set which I have. We will choose a positive ideal solution which will basically be nomenclatured as PIS, positive ideal solution of the original ranking problem which we have. So, obviously, there would be a ranking set, and ranking set in the sense they are alternative based on which we would have given some weightages to the alternatives, and we also would have different weightages for the criteria which are there in each and every alternative. So, based on that positive whole set which we have, we will find out, say for example, the positive ideal solution PIS. Similarly, if we have the negative set of solutions for all the alternatives for all the criteria, we will have a theoretical negative ideal solution which will be known as the NIS, and which will be based on the original ranking problem. Once this is done, we will find out the distances from each decisions and alternatives. So, each decision and alternative which is I is equal to 1 to m. So, A1 distance from PIS will be calculated, A2's distance from PIS will be calculated. Similarly, we will find out all the distances till we find out AM. So, distance AM is basically the alternatives distance from the PIS which we will have. Now, these distances, if you remember, I said that we will use a function or distance function which will give as distance between the two values which is AI and PIS. So, obviously, you will have the values d A1 from PIS. Similarly, you will have d A2 PIS, and we will continue finding out till the mth one. Similarly, as we have all the alternatives again from A1 to AM, we will find out the distance function from the negative ideal set also. That means, the distances from A1 to NIS, A2 to NIS would be calculated. Now, there are two questions. Question 1 is, so let me remove this. The question is that the distance function which I assume for AI with PIS which is positive, let me use a different color. So, it will be easy let me use a different color. So, it will be easy for me to specify. So, this is distance from AI, PIS is positive. So, I use the blue color. Great. And when I use the negative value, so basically I would have this function. Now, the main question is, somebody would definitely ask two things. Number one, what type of distance function which you use for finding out the first function which is dAI with respect to PIS, or dAI with respect to NIS. They can be any distance function, like we can use the quadratic utility function, hence the Euclidean distance. It can be the cubic distance, it can be Hamming distance, it can be L1 norm, it can be L infinity norm, it can be anything. So, we have to choose a distance function which basically gives us the best criteria. This word criteria I am using in a very general sense, not with respect to the criteria which are j is equal to 1 to m n, those are not. Based on the best criteria which will give us the best ranking system of the alternatives, that is point 1. Point number 2 is that the distance function which we are utilizing for AI with respect to PIS or for AI with respect to NIS, those distance function have to be same for our calculations. Like this, in the sense we cannot use the quadratic utility function or the Euclidean distance to find out all the distances how far A1 to AM are individually from PIS, and we cannot use, say for example, the n infinity norm trying to find out what is the distance function for all the A1 to AM with respect to NIS. So, if we use a distance function, it has to be same for both the sets of AIS with respect to PIS and AIs with respect to NIS. So, that is important to note. So, we will find out the distances from each decision alternatives similarly. That means, we will find out the distance AI with respect to NIS for I is equal to 1 to m. Now, we will generally use the Euclidean distance in the Cartesian coordinate, which will measure will be utilized, and we ensure our main motivation is to basically minimize the dispersion. Now, as you are trying to minimize the dispersion, the best measure of dispersion is variance. So, as you minimize the variance, minimize the dispersion, it automatically leads to the fact that you minimize the variance, and trying to minimize the variance gives you the best measure that how you can rank the alternatives to find out the best set of ranking, which will give you the best benefit for the decision maker collectively. So, we will calculate the index values Ri. So, Ri would basically be the ratio of the distance function of NIS with respect to the distance function of NIS plus PIS. So, if I basically calculate the values of Ri's, it will basically be the, I am using the general formula, it will be the square root of AI minus NI square and AI minus NI square plus AI minus PI square. So, once we have the distance function, so the basic premise or basic assumptions being the Euclidean distance portrays the concept of utility UW, which is quadratic, and if you remember, the quadratic utility function gives us the square error loss, which is the best way trying to find out that how you can minimize the utility function. Minimizing UW ensures minimizing dispersion. That means, it gives us the value that when we try to minimize the dispersion, we are also able to minimize the variance of that utility based on which we are trying to do the ranking. So, one ranks the ratios Ri's to get the best alternative, and then we will basically find out the multiplication of those matrix, which is the decision matrix multiplied with by the weights to find out how the ranking can be done with respect to each and every alternative, with respect to each and every criteria. That means, we take one criteria, try to rank A1 to AM amongst themselves, taking 2 at a time based on, say for example, the first criteria. Then we take the second criteria, try to rank A1 to AM taking 2 at a time, then we do it for the third criteria, fourth criteria till the last one, and then we basically find out the cumulative overall ranking based on the cumulative scores. So, we will very briefly state the algorithm of the Topsis method here and try to follow one of this algorithm in the very simplistic sense to solve a very simple problem. We will assume the decisions alternatives are given as AI, I is equal to 1 to m, and we will assume that attributes or decision criteria goals are given by Cj, where j is equal to 1 to n. So, you will basically have A1 to AN m as the set of alternatives and C1 to Cn as the set of criteria. So, we will basically try to find out the ranking of the alternatives based on these cumulative collective group of criteria. We state the pseudocode for the working principle of the Topsis method, and which is as follows. Now, it looks complicated, but it is not. I will just state it and then proceed with the simple problem in a very simplistic manner. So, we will basically define a set X, which would basically be the matrix comprising of the so called utility. Listen to this fact very carefully. So, X would be a matrix of size m cross n, m as in mango, n as in Nagpur. Why it is m and n? If you consider any each and every of this cell, it will mean that if I am at the 1 comma 1 cell, it will mean that what is the overall weight level of criteria weightages or the level of utility which I am getting from criteria 1 for the alternative 1. If I consider, say for example, the cell value 1 comma 2, then it will be basically be the level of criteria or the value of the criteria which I get when I basically utilize that for the alternative 2. That means, I am going by the first row, top row. Similarly, 1 comma 3 would be the effect or the overall value of the first criteria on alternative 3. Similarly, the last one which I do will give me the overall value according to where I can find out the level of criteria 1 on, say for example, the alternative m. Now, this could be reverse also, that means, if I find out the transpose, it can the overall concept will be the same. Similarly, if I go to the second row, it will be the level of output or the net value which I am getting from the criteria 2 for each and every alternative starting from 1 to m. Similarly, for the last value which I have, I will basically have the level of the value of the criteria which is basically n, and those values corresponding to the fact what are the weights given to the alternatives 1 to m. Now, if you reverse it technically, if I find it, then the corresponding columns which I would have would basically be the each and every criteria, and the rows would basically be the corresponding values of the alternatives. So, if I am considering m cross n, it basically means all the m's, the rows are corresponding to the alternatives and the columns are corresponding to the values of the criteria. So, we will consider an m cross n and continue with the analysis, and it can be changed accordingly and we can solve the problems, there is no problem in that. So, if we consider the matrix consists of priority scores assigned to the decision alternatives, where AI is based on the attributes, decision criteria, goals and goals. Considering that time is running out for this, at least for this the first class or the first lecture on the 7th week, I will pause here, end this this lecture here, and again start with the algorithm discussion. So, that means we will have much more time in trying to analyze and try to understand how the algorithm will be used. Thank you for your attention and have a nice day. Thank you.